All right, hi folks, this is Larry Mussolino. I'm recording the video for Objective 11 here in MATH022. And Objective 11, you can see, has quite a few topics. And the main focus here is working with exponents. So you can see you're going to be working with all of these rules for simplifying expressions that have exponents. Now, very, very important that you come here to the reference packet, because here is a definition of working with exponents. Here are important rules that we're going to be using to simplify these expressions. So notice there's something called a product rule, quotient rule, power to power rule, and so on. So the key here in this objective is to recognize when to use which of these rules to simplify an expression. So we'll try to do a bunch of examples here to see how this works. All right, well, first, let's come up here and talk about what is an exponent. So let's go to this first topic. It says writing expressions using exponents. Well, an exponent is really a superscript. What it does, let me give you an example. How about 5 with this superscript 2? Well, this 2 up here is called the exponent, and this 5 is called the base. And the exponent tells you how many times to multiply the base times itself. So 5 to the exponent 2 is really telling you to take the base 5 and multiply it times itself 2 times. What if I had 3 to the exponent 4? That is telling me to take the base 3 and multiply it times itself 4 times. Whoops. So really, exponents are just repeated multiplication. The exponent is telling you how many times to do the multiplication. So in this Alex problem, they're giving me 9 times itself 5 times. So I'm going to write that as the base 9 to the exponent 5. Because I just count up that there's 1, 2, 3, 4, 5 9s being multiplied. That means 9 to the 5. Okay? And that's what this description here is telling you, that the exponent is the number of times you're multiplying the base times itself. All right, let's do a couple more examples here. All right, here it wants me to just evaluate or work this out to a numeric answer. Well, the one thing I want to remember is that when I see 3 to the exponent 4, it means take 3 times itself 4 times. Well, now I could just multiply this out. Order of operations says I should be multiplying from left to right. 3 times 3 is 9. Keep going from left to right. 9 times 3 is 27. And finally, 27 times 3 is 81. So the answer here is 81. Many calculators have an exponent button on them so that you can easily evaluate this kind of an expression involving exponents. All right. Let's do an example with fractions in it. All right. Well, on this one, they're asking me to evaluate a fraction to the exponent 2. Well, again, what I have to just keep in mind is that the exponent tells me how many times to multiply the base times itself. So 3 to the exponent 2 means take the base, which is 3 over 2, multiply it times itself 2 times. But this is multiplying fractions. Well, the way you multiply fractions is you multiply straight across. On top, 3 times 3 is 9. On the bottom, 2 times 2 is 4. This is the answer. I can't simplify this anymore. So that's the final answer on this one. All right, let's do a few examples where we are going to apply some of these rules. All right. Well, what they'd like to show me on this example is 2 different ways of writing this out. All right, first they say write this multiplication without exponents. So they don't want me to use exponents at all. Well, I know y to the exponent 2 means take the base y times itself 2 times. And y to the exponent 5 means take the base, take the base y times itself 5 times. So this is the answer for part A of this question. They just want me to write out y times itself really 7 times. I have 2 y's here and 5 y's there. So altogether, y is being multiplied by itself 7 times. Well, now in part B, they want me to put the exponent. Well, if y is multiplying itself 7 times, that means I should write it as y to the exponent 7. So in this box for the exponent, I'm going to put the number 7. This also illustrates a rule, a shortcut rule. Because if you have y to the 2 times y to the 5, there's a rule that says you can simplify this by adding the exponents together. So if I add the 2 plus the 5, I get the 7. And that's what this product rule actually says. The product rule says if you have the same bases being multiplied, they use the letter B here for base. If you have the same bases being multiplied, you keep the base the same and add the exponents here. So let's do another example of this rule. It's called a product rule. So let's do another example like that. This is an important rule because you're going to use this quite a bit. All right, here it is. So they're giving me v to the 3 times v to the 2. Well, the rule is when I have the same bases like this being multiplied, you keep the base the same. So I'm just going to copy the v over, and you add the exponents together. So that's going to be 3 plus 2. Well, that's v to the 5. So the answer here is just v to the 5. I'll give you another example. How about x to the 7 times x to the 3? Well, you keep the base and add the exponents. This would be x to the 10. What if I had x to the 5 times y to the 12? Well, for this, you cannot simplify because this product rule only works if the bases are the same. Here, the base is x. Here, the base is not the same. The base is y. If you have different bases, like this example, you cannot use this product rule. The bases must be the same, like x and x, to use this product rule. All right. Let's do another example here. It's a little more complicated. All right. So here's what they're giving me. Kind of a messy expression. 3x times 2y to the 5 times 8x to the 3, y to the 5. All right, well, the first thing I want to mention to you is anytime you see a variable like x or y with no exponent written, the exponent 1 is implied. So if you see x, it's really the same as x to the 1. If you see a y, it's really the same as y to the 1. So I'm going to come here to this x. I'm going to put the exponent 1 here just to make it a little more obvious that that's the exponent that goes along with that x. All right, now here's what I could do. I am allowed to reorder any multiplication. The order of multiplication doesn't matter. So if I want to reorder a multiplication, I'm free to do that. Well, I'm going to do that just to make this a little easier. I'm going to put all the numbers next to each other. So here are all the numbers next to each other. Then I'm going to put the x's next to each other. Then I'm going to put the y's next to each other. I don't have to do this, but I think it's a little easier to organize the analysis. Well, for the numbers, I could just multiply these together. 3 times 2 is 6. 6 times 8 is 48. So that's 48. Here I have x to the 1 times x to the 3. Well, this product rule says keep the base the same and add the exponents. So that's going to be an x to the 4. I'm going to do the same thing for the y's. Y to the 5 times y to the 5. Keep the base the same y, add the exponents. 5 plus 5 is 10. I have to stop now. I can't do anything else to simplify this because now I have an x to the 4 times y to the 10. But those are different bases. I can't use the product rule anymore. So this is the final answer on this one. All right, so reordering the expressions is an option to help you kind of organize and make the problem a little easier to work with. All right. How about if we come here? All right, let's take a look at this one. All right, well, this one is a little different. This is called a power of a power, because what this is an exponent, the exponent 4, but that expression is being raised to another exponent, the exponent 5. So let me look for a rule that might help me out here. Let me come here. It says power to power rule. Yeah, that's what I have. I have a power. By the way, the word power is the same as the word exponent. So instead of using exponent, you can use the word power. So this is x to the power 4, and that's being raised to the power 5. So it's a power to a power. Well, notice what it says here. It says if you have one exponent being raised to another exponent, you keep the base the same, but now you multiply the exponents together. So for this one, I'm going to keep the base as x, but now I multiply the exponents together. 4 times 5 is 20. Okay. Notice this is a different expression than if I had x to the 4 times x to the 5. This is where I add the exponents together. That would be x to the 9. So you have to be on the lookout and be careful, because in some cases you multiply the exponents. In other scenarios, you add the exponents. That's why you have to take the expression you're given and match it up carefully to this table here of properties of exponents. All right, let's do a couple more. All right, let's take a look at this one. All right, now this one seems to be a little different because it's a multiplication inside the parentheses, but with another exponent sitting out inside. So I'm going to come to this rule right here. I'm going to make this, hold on, let me make this a little bigger to make it easier to see here. Let me zoom in on this. Okay, yeah. So what I want to focus on here is this expression right here. Because I have a multiplication inside the parenthesis being raised to an exponent. And notice what this is telling you to do. Take the exponent n and apply it separately to the a and separately to the b. This is almost like a distributive property for exponents. So what this says is when you have a multiplication inside a parentheses that's being raised to an exponent, you take this exponent and you apply it separately to each expression inside the parentheses. So I'm going to do that. It's going to be -7 to the exponent 2, v to the 4 to the exponent 2, and u to the 2 to the exponent 2. All right, well, -7 to the 2, that's -7 times -7, but that's positive 49. So this is a positive 49. How about v to the 4 raised to the 2? Well, that takes me back to this rule. When you have one exponent being raised to another, that's when you multiply the exponents together. So I'm going to multiply 4 times 2 and get 8. Then for u to the 2 raised to the 2, I'm going to multiply the 2 times 2 and get 4. So here's my final answer. I can't simplify that anymore. So that's the end result here. All right, let me do a couple more examples. Let's talk about the quotient rule. All right. So here's a rule that's called the quotient rule. Let me scroll back up here. All right. Here's the quotient rule. What this rule says is if you have one base being divided by another base, the bases have to be the same. You keep the base, but now you subtract the exponents. So in our example, let me give you another example. How about if I had x to the 10 divided by x to the 6? This rule says keep the base x the same, but subtract the exponents. So this would be x to the 4. So in our example, we could do the same thing. Keep the base the same, b, but subtract the exponents. Well, 5 subtract 3 is 2, so the final answer here is b to the 2. All right, this is called the quotient rule. Quotient means division. All right, let's look at a couple more example. What if we look at this one? All right. Well, for this one, it's a similar kind of example, but we have a mix of A's and B's here. Now on the bottom, notice I just have a plain old A, but I'm going to put an exponent 1. Remember, anytime you have a variable by itself, you can put the exponent 1 there. All right, now I'm going to use the quotient rule for each one of these letters. Let me look at the B's first. Well, that quotient rule says keep the base the same and subtract the exponents. I'm going to do the same thing for the A variable. Keep the base A, subtract the exponent 6 minus 1. Well, 5 subtract 4 is 1. And for the A, 6 subtract 1 is a 5. This answer is okay. Usually, though, when you have an exponent 1, we don't write it. So really, we could write this as just B times A to the 5. You could leave the exponent 1 there if you want to, but usually we leave it out. All right, let's see if there's anything else. Let's go one more here. All right, this one's a little tricky because there's going to be several steps involved here. All right, now, folks, when you have a complicated expression like this, what you want to do is try to match up the expression you're working with to one of these rules and then try to simplify. You might then need to apply another rule to simplify further. So what you do is you keep applying these rules until you can't simplify the expression anymore. All right, let me look at the top of this fraction to begin with. If I look at the top of the fraction, I'm noticing it's a multiplication inside the parenthesis being raised to the exponent 3. Well, that seems to remind me about this rule where you have a multiplication inside the parenthesis raised to an exponent. Well, remember that says this exponent n applies inside the parentheses. So I'm going to let this 3 apply inside the parentheses. So I'm going to write it as 3 to the 3 and then y to the 6 to the 3. I'm going to do the same thing on the bottom of the fraction. This exponent 2 is going to apply to the 6, and it's also going to apply to this y to the 3. All right, let me keep going. Well, 3 to the 3 I can work out. That's 3 times itself 3 times. 3 times 3 is 9. 9 times 3 is 27. So that's a 27. All right, how about this? Y to the 6 being raised to the 3. Well, that's this power to power rule. I have one exponent being raised to another. Remember, that's where you multiply the exponents together. 6 times 3 is 18. All right, let me go to the bottom. 6 to the exponent 2. That's 6 times itself 2 times. That's 36. So that's going to be a 36 here. And now I have y to the 3 raised to the exponent 2, but that's where you multiply the exponents. So that's y to the 6. All right, I'm almost done. First thing I'm going to try to do is, can I simplify this fraction here, 27 over 36? Any way to simplify that? Well, yeah, I'm noticing that I could divide 9 top and bottom. 27 divided by 9 is 3. 36 divided by 9 is 4. Now, let me come to this y. I have y to the 18 over y to the 6. Well, that's the quotient rule. That tells me to keep the base the same, but subtract the exponents. So that's going to be 18 subtract 6. But 18 subtract 6 is 12. So here is my final answer. All right, folks, so notice in this example, we used several rules to simplify this. Right, this first rule we used here was called the product to power rule. Then this rule here was called the power to power rule. This rule here was called the quotient rule. So at each stage, you look at the expression you have and try to match it up to one of these rules and keep simplifying until You can't simplify any further. All right, folks, hope this is helpful as you're working in this objective.